Day 526 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again. Another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 3186, maximum total damage with spell casting. The difficulty level is medium, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. A magician has various spells. You are given an array power where each element represents the damage of a spell. Multiple spells can have the same damage value. It is a known fact that if a magician decides to cast a spell with the damage power of I, they cannot cast any spells with the damage of power of I minus 2, power of I minus 1, power of I plus 1, or power of I plus 2. Each spell can be cast only once. Return the maximum possible total damage that a magician can cast. All right, y'all, so that sounds simple enough, but let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. So in example 1, we have our input power equals an array of integers 1, 1, 3, and 4. Our output is 6. Explanation says the maximum possible damage of 6 is produced by casting spells 0, 1, 3 with damage 1, 1, 4. So let's break this down one step further. So we have these requirements right here that we have to follow when we're casting our spells. So we cannot cast a spell if the spell damage, or first say we cast, if we decide to cast a spell with the damage of power of I, we cannot cast another spell with the damage of power I minus 2, power of I minus 1, power of I plus 1, or power of I plus 2. So when we look at this example, you can see this represents the index, this represents the damage. So let's just look at the damages for now, so it can make more sense. So as you can see, when we use this spell, right, this spell has a damage of 1. We cannot use any other spells that have a damage of -1 because 1 minus 2 is -1. We cannot cast any spells that have a power of 0 because 1 minus 1 is 0, right? And then we cannot cast any spells that have a power of 2, or we cannot cast any spells that have a power of 3. If we cast this first spell, or if we use this first spell that has a power of 1, right? So we can't cast any other spells that are +1 or +2 or -1 or -2 of this spell power. So but that does mean we can cast this spell as well, because these two spells are equal to each other. They're not one more or two more, and they're not one less or two less. They're equal, so we can cast both of them. Boom. Then we get right here to 3. We cannot cast 3, this spell that has a power of 3, because 3 is 2 more than 1, right? And so it says right here, we cannot cast spells with the power of I plus 2. So since 3 is 1 plus 2, we cannot count 3, or we cannot use 3 if we're going to use these two ones. So we have to skip this 3. However, we can use this 4 because 1 plus 3 is 4, and there are no rules up here that says we cannot use a spell that has a power of I plus 3. And in this case, 4 is plus 3, so we can use 4. So in total, we can use these two ones because they're equal, and then we can use this 4 because it's plus 3. It's not +1 or +2 or -1 or -2. So we can use this 4. This 4 fits the requirement. And in the end, we can use these two spells plus this 4 power spells, and in total we have our spell has a power of 6. So just in case that didn't make sense to y'all, let's take a look at example 2. So in example 2, we have our input power equals an array of integers 7, 1, 6, and 6. This time our output is 13. The explanation says the maximum possible damage of 13 is produced by casting spells 1, 2, and 3 with the damage of 1, 6, and 6. So let's break this down as well. Same principles apply. So it says we're using this right here just means indexes 1, 2, and 3. So as you can see, this is index 0. This is index 1, 2, and 3. So as you can see, index 1, 2, and 3 have damages 1, 6, and 6, right? So we're looking at these. And these fit the requirements. Once again, we could see if, say we started at 7. Let's go over why we can't use 7 or why we shouldn't use 7. So say we use this 7. If we use this 7, that's all fine and dandy. Then we can use this 1 because 1 is 6 less than 7. So we can use this 1 because it's not 1 less or 2 less or 1 more or 2 more. So we can use this 1. But then, so now we have a total spell power of 8. But then we can't use these 6s because the 6 is 1 less than 7, right? And it says right here, power of I minus 1. We cannot cast any spells with power of I minus 1. So 7 minus 1 would be 6, which means we can't use these two 6s, which means if we use the 7, the greatest spell power that we could have or achieve will be 8. So we're going to keep going. We saw how much damage we could do if we start with 7. We're going to keep going, and we're going to see how much damage we could do if we start with 1. So if we start with 1, then we could use the 7, but once again, if we use the 7, then we can't use these two 6s. So we're gonna hold off on using the 7 until we see what these two 6s can do. So we hold off on the 7. We start with our power of 1, then we go to this 6. We can use 6 because 6 is 5 more than 1. Once again, it's not 1 more than 1 or 2 more than 1. It's 5 more than 1. So we can use this 6. Boom. Then similarly, we can use this 6 as well because they're equal. It's not 1 less or 2 less, and it's not 1 more or 2 more. So we can use this 6 as well because it's equal. And in total, if we use this 1 and these two 6s, we could get a power of 13, which is the total or the maximum possible damage that we can produce if we went through all of the different ways we could use our powers. So in this case, the output would be 13 by using these 3 powers right here, or these 3 spells right here, and that's how the question works. So I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. Solution is not that difficult at all. Now, the first thing we want to do is we want to get the number of elements in the power array. So to do that, we're going to say, we're going to come over here and we're going to say let n equal power dot count. Boom. Then we're going to sort the power array in ascending order, and this sorting is going to help group equal or close values together for easier processing. So we're going to say let power equal power dot sorted and put the parentheses at the end. Boom. Then we're going to create our DP array, and this will store the maximum total damage achievable starting from index I and initialize all the DP entries to 0. So we're going to declare a variable called DP, set that equal to an array, open up the parentheses, repeating, :0, comma count, :n plus 1. Boom. Now we're going to come underneath this, and we are going to create a recursive helper function that returns the maximum total damage starting from a given index. So we're going to create a function. We'll call it helper. We're going to open up the parentheses, say underscore, start. Then we're going to say :. That's going to be an integer. We're going to set it equal to 0. Come outside of the parentheses. It's going to return an integer. We're going to open up the brackets. Boom. Now, our base case is if start goes beyond the last index, then no damage can be added. So we're going to say if start is greater than or equal to n, then we could just open up the brackets and return 0. Boom. And then if DP start has already been computed, we can return it using memoization. So we could just come underneath this and we can say if DP square bracket start, come outside the square bracket, is greater than 0. Then we can open up the brackets and say return DP square bracket start. Boom. Then we're going to find a range from start to end of elements that have the same value as power start. So we're going to come underneath this. We're going to declare a variable called end and set that equal to start. Come underneath this. We're going to say while end plus 1 is less than n, and 2 and signs, power square bracket end plus 1, come outside the square bracket, equals power square bracket start, come outside these square brackets, we're going to open up the brackets, and we're going to say end plus equals 1. Boom. Then we're going to find the next index next where the power is strictly greater than the power start plus 2, and we're going to skip all of the elements within 2 units of power of start. So we're going to come underneath this while loop, and we are going to say, or we're going to declare a variable called next. We're going to set that equal to end plus 1. Then we're going to come underneath that, and we're going to say while next is less than n and 2 and signs, power square bracket next, come outside of that square bracket, is less than or equal to power square bracket start, plus come outside that square bracket and say plus 2. Then we're going to open up the brackets, and we're going to say next plus equals 1. Boom. Now we have 2 choices. We're going to pick all of the elements from start to end, and then that will we'll set, or hold on, let me show y'all first. So we're going to come underneath this while loop, and we're going to say dp square bracket start equals max, open up the parentheses. We're going to open up so it's cleaner than y'all, for y'all, just so it's a little bit cleaner for y'all. I'm gonna come down like this, and then we're gonna open up some more parentheses. We're gonna say end minus start plus 1. Then we're gonna come outside of those parentheses and say times power square bracket start plus helper, open up the parentheses and pass in next. Boom, come outside of that and say comma. Then we could just, after the comma, we could come underneath that, we could say helper, open up the parentheses, end plus 1. So we have 2 choices. We're either going to pick all of the elements from start to end, and so that's going to be end minus or end through start plus 1 times power start, that's this one, or we could just skip the group entirely and move to the end plus 1, which is this right here. Boom. Then we need to return the computed maximum for this sub problem by coming right here underneath this parenthesis right here, and we are going to say return dp square bracket start, and then finally we're going to start our recursion from index 0 by coming right here and say return helper. Boom, that should be all she wrote, y'all. Let's give it a run. Make sure, okay, we got an error. So let's see. Consecutive. Let me see, y'all. Just a minute, y'all. Let me see what's going on here. Let me see. Well, first, ret run. Where do we even have? Oh, wait, no. Where do we even? Oh, right here. Sorry, y'all. Ret run. That should be return. Now let's give it a run. See if that works. Okay, where's this one? Oh, we gotta put the parentheses. So add some parentheses. Let's run it again. Let's see, and look at that, it's accepted. So let's go ahead and submit it. Make sure it's still accepted after we submit it. And look at that, y'all. 91 milliseconds beats 100% of users. That's what I'm talking about. That's what I like to see, y'all. So with that being said, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.